So Raffaello, thank you for joining us today. You've developed some amazing robots that play soccer and ping pong. What novel potential uses do you see for robots for business and society in the future? And where are we liable to see robots next?
I think in the short term, I think the biggest impact is going to be from how we make things. So, how we extract things from the ground, mining, agriculture, how we make things, manufacturing, and how we distribute them. I think we're going to see a lot of that innovation find its way in these sort of realms in the next 3 to 5 years. I still think we're a bit of ways away from the general purpose robot in your home that's going to, do your bed, do the dishes, etc. But I think we also see in the medium to long-term infiltration of automation and robotics in the home.
A lot of your research has been around learning systems and learning robots. Just following up on that point, the driverless car, the self-driving car, do you see applications of learning algorithms?
One of the biggest advantages of learning and adaptation is that it allows you to create powerful systems that are inexpensive to make. If you try to make a very precise robot, it costs a lot of money. If, however, you relax that requirement to make a machine that right off the bat is high performance and let it learn and adapt to become high performance, it becomes economically viable to deploy such a machine. So I think learning and adaptation is going to have a huge impact in how we make machines.
What has changed, either in terms of the underlying technology or the economics of robotics, that over the last few decades, and how do you see it changing going forward?
I think a lot of it is probably best thought of as kind of reaching tipping points. And let me make an analogy. Let's say you make a robot that could do something, and that it costs $1.25 for it to do that, and that person can do the same thing for $1. Then you're not going to use that robot. But next year it takes 5 cents less to do it, so it becomes $1.20, and then $1.15, $1.10. Now, from an outside perspective, you may say there's no progress being made in this technology. Yet, as soon as that tipping point comes when this robot could do this thing for $1 or less, all of a sudden it becomes economically viable, and everybody jumps in to adopt it. So I think that there has been a steady progress in the development of robotics and automation, but I think we've just reached various tipping points that'll make them all of a sudden economically viable to deploy.
What kind of systems innovations are you seeing? And if you think about this from a company perspective, are there interesting startups or maybe lessons even for the more established robotics players?
I think some of the neat things that the big companies are doing is using robots in a cooperative fashion, which is really, a lot of people think that that's been going on for a long time, but actually that's not true. So for example, having multiple robot arms work together to manipulate objects for manufacturings, for installations, etc. That's a pretty new development. And a lot of the big companies, robotics companies, are exploring these ideas. Also integrating different types of automation technologies together. I think that's an exciting development that big companies are mainly undertaking. I think in startups, what really gets me excited is the folks that are looking at new ways to do location and navigation. So if we really want robots to be pervasive, autonomous systems to be pervasive, they need to know where they are. Not just outdoors, but also indoors. So I think it's interesting, there's a lot of startups that are trying to solve this problem by using advances in computer vision, advances in other types of sensors, inexpensive sensors, accelerometers, rate gyros, magnetometers, you name it, other wireless types of technologies, and really the algorithms to fuse all that information together and provide a local awareness for autonomous systems that just doesn't exist right now.
Your startup, Kiva, was acquired by Amazon with the hope of using its robots to move items around in the warehouse to get products to consumers faster and also at a lower cost. Robots reportedly have been deployed in a warehouse with over 1,000 robotic workers in Massachusetts, which just sounds amazing. What's the long-term potential you see for Amazon's move? I recognize you may not be able to comment specifically about Amazon, but in general around warehouse logistics, warehouse management and distributions and operations going forward.
What's interesting about Kiva was that the original business model, the key value that we thought Kiva was bringing to the space was cost. We thought that here's a system that will allow us to reduce the cost of filling orders. But it turns out that it was many of our secondary value addeds that were really exciting to customers, and that was flexibility, adaptability, reduction in errors and human errors. And really this flexibility and adaptability part, the fact that you could set up a warehouse in 6 weeks instead of 2 years, the fact that if you wanted to reconfigure the warehouse, it was easy to do that, which you couldn't do with existing automation. So I think the lesson there was that businesses really want flexibility and adaptability.
Do you see applications of Kiva's technology outside of warehouses and maybe more in a manufacturing environment?
Absolutely. We always thought about manufacturing when we were, growing the company, but we were really, focused on distribution. And there was just so much opportunity in distribution that we said, well, manufacturing will come later. Maybe we'll spin off another company. Maybe we'll start another division. And, that still may happen. The underlying ideas can certainly be brought to manufacturing.
There's been a lot of discussion about big data and companies hiring decision scientists. Are the underlying skill sets very similar, or should companies be thinking about hiring control engineers as well?
The right answer is somewhere in between. You can try to model absolutely everything and never look at data, right? And try to predict, this is what the Greek philosophers used to do, sit around and try to think of how the world works and forget about observations. There should be a way to think things through. That's one extreme. The other extreme is forget about trying to have any understanding of the physical world. We're just going to look at data, and the data is going to tell us what causal relationship should take place and how the world works. We like to do things in between. We like to have physical models. We like to sit on the shoulders of giants that have developed all of this understanding of how the world works. But we also like to use real physical data to augment our models, to refine our models, to tell us where our models have deficiencies. So, and the more data you have, the better you can do that. I think there's a lot to be gained by combining those two approaches. So folks that are only big data, I think that's limiting. Folks that can only do modeling, I think that's limiting. I think you need people that can do modeling and that can work with big data.
Systems are inherently unpredictable when you start connecting them and there's more and more complexity. Are there any cautionary tales you would have for business leaders of how behaviors could be unpredictable around business systems?
There's many examples of when feedback can cause things to go wrong, or interactions with the environment. One example that comes to mind is the Tacoma Narrows Bridge.
I remember that video well.
Exactly. Basically this bridge was designed, and people didn't really take into account the interaction of the bridge with a constant flow across the bridge, and that caused this bridge to become unstable and it collapsed. There was Chernobyl, which was basically a system that ran wild, that went unstable because of various feedbacks that caused a positive runaway cycle. I think the lesson here is that you really need to feedback is very powerful, but it's also very dangerous. You have to be very careful when you start feeding things back without some sort of supervision, because you get unpredictability. So, it's a two-edged sword. You want to harness the power, yet at the same time you don't want things to go wrong. How do you get around that? One, try to understand things before you connect them together and try to predict what could go wrong. You can do that by simply trying to understand the system and trying to reason through it, but also, you can make simulation models, agent-based models, you name it. I think that's the first part. And the other one is just to be cautious, try things out, see how it works, because you can't prove, for really complicated things, it's very difficult to prove that something is going to work when interconnected. A lot of times you just have to try it out.
Raffaello, I want to thank you. Your research is fascinating and it's been very interesting. And I think there are a lot of lessons for us in the business world.
So thank you very much. Thanks for having me.